First of all, I'm sorry for my very bad English, but I'm going to try. Can you see my presentation?
I can, yes, yes.
Yes.
Okay, thank you. As said Dr. Merino, I want to tell you about the recovery of interesting substance from industrial and real and industrial sludge generated from wastewater treatment of scallop culture or farming industry. As you know, the marine bivalves are very important for the food and also for the economy. In this respect, the north of Chile, the south of Peru, also the culture of Ostión del Norte, or important. Too many people work in this industry, so it's very important for our economy. And this organic, this scallop is cooked in suspended systems. As you can see in these pictures, the scallop, or ostión, we say it in Chile, is cultured in this kind of system. Is a lantern, dried and empty lantern. And here you can see in this picture the lanterns or the pernet in the water. But there is very different this photo from this ones. Here you can see the lanterns are full of fouling. Fouling is the accumulation of invertebrates and microorganisms that progressively settle in this system. So the pass of the water and the nutrients for the scallop is very difficult. So it's a problem for the scallop cultures. To solve this problem, the lanterns and the suspended system are to be cleaned in high pressure machine. So use water to clean this kind of system. So is used very high amount of water to clean this system, producing a high amount also of wet and saline sludge. In this picture, right, you can see workers that they are working with the high pressure machine, dirty lanterns. The idea is to clean it to get something like that, very different. In this process is produced, as I said, wastewater and also this kind of sludge, very dark, very concentrated. But here in Chile, also in other parts of the world, we suffer a drought, the reduction of the rain. If is very important. Water and other substance from this kind of sludge. Here you can see the wastewater on the sludge. There's a problem because the company needs to manage this kind of wastewater and sludge. But as was said, we are suffering a drought that affects the north of Chile and several other places. But obviously, it's very important to produce strategies to recovering water from the sludge and other one of the technology to produce this kind of recovery is the use of reverse osmosis system. A very strong technology, very effective, very expensive too. Also, it requires a lot of energy and excessive maintenance. So we think that it's important to develop other kind of technology to get a recovery of water. An interesting use of the thermal process as the multi-effect distillation, multi-stage distillation, and the humidification process. Those kind of technology use thermal system to remove the water from the wastewater or from the sludge, and obtain a clean water in other places. In the case of the humidification and the humidification process, we have a hot sun produces the humidity, and this vapor is conducted to a cold to obtain a condensation system. If you have any question, you can interrupt in any moment. You can feel free, please. This system, HDH system or humidification, the humidification system is a low cost, simplicity. You don't need a very high temperature to produce vapor and can be used in any places. And the other interesting issue is that you can use it to produce the humidification process or the hot zone of the process. The water quality. As I was saying before, with this system you can get a fresh water, but we don't know if this we can use it to drink or to irrigation process. So the water quality is very important in this case. We need to think that industrial sludge that can be very polluted. So maybe the fresh water obtained in the condensation system could not be very clean. Aspect to consider is the presence of suspended solid, this solid, total dissolved solid, chemical oxygen demand, biological oxygen demand, between several others. Obviously, distilled water. In this system, we are distilling water. So we can infer that the quality is very good. It's very good. We don't have the suspended solid. The COD, BOD, or TOC could be very low. Also, the salts or electrical conductivity. Very good, no problem. But what about with the microorganism? This could be a problem. Again, if you see that, we are obtaining a vapor and also small transport microorganism. This kind of transport or microorganism is called airborne microorganism. So we can obtain in the condensed water clean water, but could be the presence of some microorganisms as bacteria, fungus, viruses, or others that need to be controlled to avoid problems related with the quality of this water. Several studies that in these rivers we can obtain some pathogens that can produce meningitis, hepatitis, and several respiratory disorders. The idea is that we need to mature this kind of water. If we detect the presence of microorganisms, we need to conduct a disinfection process. A case of study that we decided in the university here in Coquimbo. We are very near of several scallop cultures. In this case, in Coquimbo, that is around 1 hour to near here. In Coquimbo, they culture Agrobacterium purpuratus. That is a scallop, the ostión del norte, as we say in Chile. That is cultured in lanterns or pernets. Here in this photo, you can see the pernets full of fouling. We have take from the water to clean in high pressure machine to go from this to this. Yeah? But it produces a wastewater and a sludge that we have recovery water from this sludge. For this study, we work with a sample of 200 kilos and 50 kilograms. It was a very salinity and wet sludge with a 73% percentage of water, and was submitted to a solar drying process. For this sludge here in this solar distillation process that has a sunroof was made from polycarbonate, a transcarbonate, that has a thermal conductivity of 0.2 watts meter Celsius, and thermal of 80%. In brief, it is a entrance of solar irradiation to reduce a greenhouse effect. So the heat is mainly maintained in this area, promoting the production of vapor in the hot zone of the humidification process, using this structure to conduct to a heat exchanger system and obtain a control of the dehumidification process. To promote the air circulation, we use a solar heater that get air from the atmosphere and is heated in the system, as we can see in this diagram. In this system, the air is heating and come inside of the solar drain armature. To compare this system another, we use a parameter this called amount of accumulated solar irradiation that allow us to quantify the amount of energy that is used in the system. For this, we get a series that use the quant of energy in time n minus 1 plus the time of measured multiplied by solar irradiation, the area of the system, and the mass of the sludge. So we have a series of time, and we are quantifying the solar irradiation accumulated in the system. The coefficient of performance of the solar array heater is determined using this formula that is a ratio of the energy of the solar array heater divided with the power of the blower used in the system. Of energy used by the solar array heater is considered the velocity of air. The solar array heater, the heat capacity of the air, and the difference of temperature between the outside and inside of the system. So we can consider it system as a quantity of energy where we are going to come inside of the solar dryer. Any question at the moment? As was said before, it's very possible that in this water we can obtain some microorganisms to control and disinfect. For this issue, we have a system in three reactors. One of these use a UV lamp. The other one use a UVC lamp, and the other one use a UVA or UVC lamp plus ozone. So we have this system that we can compare the efficiency of the disinfection process. UVA A lamp use a lamp that emits a, a wavelength of 365 nanometers of UV. For UVC, we use a lamp that's emit to 254 nanometers of UV wavelength. As you know, it's very important to consider the amount of energy used in this process and also the efficiency of this usage. So the performance energy is very important considering the cost of the process. For this scale, electrical energy per order, it was a formula created by Bolton et al. That consider the power of the, the equipment, the time of use, and also the volume of the water to disinfect and the concentration in the beginning and in the final of the disinfection process. So we expect to get electrical energy, but if it is low, it means that we have a low energy consumption and very high disinfection process. The results of this case of study show us that very high temperature inside of the solar dryer and also in the solar air heater. In this plot, you can see the temperature of the air inside of the solar heater and inside of the solar dryer. Obviously, the peak is around middle of the day in a sunny day, and the low values is related with the behavior in night, or in a day with a low solar irradiation. Considering the coefficient of performance of the solar heater, we get a very interesting value of 3.9. It is very good because say us to we high temperature difference and very low energy consumption. This is a very good news. In the bottom plot, we can see the temperature of the temperature of the ambient inside of the solar dryer and the solar irradiation. What about the water recovery in this system? It was very good. We obtained a very high amount of water. We need to think that in this system, we get three catch in the system, going from this value to a final value of around 1.5 kilograms of sludge. So we get a very good dryer process and also a water recovery from that. But we measure and control the volatile compounds and the airborne microorganisms obtained in this process. we obtain these values of bacteria concentration, CFU per millimeters. So we need to disinfect this process. And you can see the evolution of the concentration of bacteria in the time after 1 hour process. And as you can see, the best performance was obtained when we used UVC and a system. We get a very good performance, very fast too. So it was a very good. To understand this very good performance, we need to consider that also of the and ozone, we are producing hydrogen peroxide. As you know, this reagent is a very good disinfect products that allow us to get a very good disinfection system. So inside of the hub UV, we have ozone and also the production of hydrogen peroxide. But we infer that we hypothesized this production, and to confirm this behavior, we conduct an experiment in clean water and measure the production of hydrogen peroxide under this condition of ozone and UVC. And in this plot, you can see the production of hydrogen peroxide and also the temperature of the system. What is the reason of this heating system? What also the UVC lamp emits heat, and this heat is dissipated in water, and is related with the production of the ozone, and also is reported a very good diffusion of ozone in the water, enhancing the production of hydrogen peroxide. Also, the generation of hydrogen peroxide is also related with the formation of hydroxyl radical. The hydroxyl radical is the base, is the reaction process. In fact, it's very difficult and expensive to measure hydroxyl radical. It's very expensive to measure it. It's very complex to measure it. But indirectly, we can infer the production of hydroxyl radical across the measure of hydrogen peroxide. Do this equation. In presence of hydrogen peroxide, we can obtain hydroxyl radical. And as you know, hydrogen peroxide is a very good disinfect product that reacts with the cells. What about the water quality of the distilled water? At the beginning, from that, we take samples and we can make sure that it has also some a little of organic matter. As you know, as you can see in the bottom plot, we have an initial concentration of total organic carbon that is now zero. Is it possible that some volatile compounds that travel with the vapor are condensed in the distillation system? So we have a microorganism and also some organic matter. Along of the disinfection process, we can obtain but also we observe an increase in the concentration of total organic carbon and chemical oxygen demand. Why is the possible reason? We think that in the process and along the bacterial destruction, some organelles inside of the cell is exposed to the water. So maybe we water at the beginning, we have proteins, DNA, enzymes, and other cellular components that increase the concentration of organic compounds in the water. But after that, in the minute 40 and 60, we observe a reduction of that. And this reduction also is very fast when you use UVC and ozone. This is a very good reason, a very good news, sorry. As we said, the generation of ozone and UVC produce hydrogen peroxide. This hydrogen peroxide, in presence of ozone and UVC, produce hydroxyl radical and oxygen. That has a very good performance of disinfection that allow us to obtain a very good water quality. What about the energy performance? It was calculated using this formula. You can see the plot of the figure of merit, what was calculated using this formula. As you can see that UVC and the more efficient energy consumed. That is related with the power of the equipment and also and when we use it ozone, the efficiency performance is not very good, but very efficiently in respect to the disinfection process. Sludge generated. This sludge has these measures that we can observe that has a very phosphorus, potassium, boron, also has amount of copper and iron. But could be used for application process, but we need to consider the presence of these metals that we need to be removed. Final considerations, the water in the sludge after the cleaning of the long times can be recovered in a humidification process, and we need to be disinfected. The solar steel was improved using the solar heater that allow us to increase the temperature inside of the system. We get a very good amount of water recovered that allow us a very good solution in a critical region during the scarcity of water. We get a very high disinfection efficiency using UVC and ozone. We need around 60 minutes to this process. The second efficiency process was the use of just UVC. The ozone allow us an enhance in the disinfection process, but also a high energy consumption. And this is it could be possible to application of the dried, sorry, it's dried, not dyed, sludge in the agriculture issues. This is my presentation. If you have any question, please tell me.
Thank you, Rodrigo. There are some people also from Ecuador. So you can also, if you want, speak Spanish to them. If the people from Ecuador cannot speak any English, we translate the question for the people that are listening from Turkey. Well, parece que es una mañana muy callada en Ecuador. It seems to be a very quiet morning today for everyone.
Maybe it's too early.
Yeah, I can read the messages, but there are no questions in the messages, Rodrigo. There are thank
Maybe
you
R.
from,
Burgos has a question.
as always.
Yes, I am thinking a question. Yes, this is true.
So please.
That what's happening with a fresh fouling? Because I don't know anything about fouling in freshwater ecosystem.
The freshwater obtaination process?
Yeah.
Yeah, the quality was very good. I show you some results, but it is just a resume. What is here? Here we have a low, very low, but is awesome. We didn't get we didn't observe that solid. It was expected, so it's very good. But yes, we have some this organic matter. So we need to. Well, we can use this water. The problem really the carbon is very low. The real problem is the presence of a microorganism. This is a parameter that we need to control. This was the reason of the disinfection process.